The last time we talked, we had there was this Adafruit example of doing, I don't know, people say duplex communication. I don't know if that's really duplex communication or not, but anyway, it was sending and receiving off of one board, and they had some sample code out there to send and receive off of 2 LoRa boards. I happen to be using this, what's referred to as a TTGO ESP-32 LoRa board. And it didn't work. This happens to be using this Radiohead, I guess, manager and library and drivers. It's a quite sophisticated set of code that the guy has made available. But it was obviously focused on their board, struggled mightily to get it to initialize, to get LoRa initialized. And so ultimately did get it to work. And this is what that code looks like. And again, this is just purely to get LoRa to fire up, because I'm assuming the rest of the code will work reasonably okay. But part of the issue with this Semtech or TTGO implementation of the Semtech chip is there's actually multiple SPIs going on this one for the OLED screen, one for the LoRa communication, and I guess one for just the base SPI stuff. So getting those pins defined, pulling in these 2 libraries, initiating this, and don't put parentheses behind that RF95 or it won't work. That was a pain in the butt. And then getting this particular statement defined, and then using the manager, which is a part of this function call, maybe. Using that to say if it's been initiated. That was sort of the secret sauce to get the LoRa to work. So it was, you know, for somebody who knows this stuff backwards and forwards, and like they'd probably say, that's simple and that's easy, but getting that 1, 2, 3, 4, 4 or 5 things configured correctly was a bit of a challenge, but now it works. One thing I added is just turning on the LED to show that LoRa had been initialized, because I will say maybe 10% of the time, 20% of the time, it does fail to initialize. And I don't know if I can improve that percentage by putting a delay or something in here. So there might be a way to improve that from a coding standpoint, but that's an issue that I have at the moment, that if I were using this in the wild, firing up these boards, 10% of the time LoRa still seems to fail to initialize. So that's where I'm at on that. So now I can go back to this Adafruit code, which is this basic send and receive example. And I don't, when you do this pre-compile, I'm going to say pre-compiler stuff. There's probably a more technical way to describe this. I'm not adept at how to set that. So like, where do I set, if I wanted to try to update this, my board, do you mind educating me a little bit on how this pre-compiler stuff works?
I'm assuming that where it says ESP, what are the things you got highlighted? So that'll be defined somewhere, like out in a header file or somewhere. So when you loaded up the package to do the ESP32 stuff, it's going to have something in there saying processor type, or somehow they define that. So if it when it starts up, if it goes digging through the code and finds that, then it will use that. And if not, see the other things there, they just got some of the stuff commented out or whatever. So it may or may not be defined in what you're doing.
So
And somehow you can probably search for that. I maybe just go to the libraries and maybe do a grep on all files and search for that word. It's probably in a header file somewhere.
Because it's got these other ones, right? So it's saying, hey, I mean, what they've done is slick code to say, if it's this board, use these. If it's this board, use these. I just didn't know how to find where is it setting the board type. Because it's not actually saying that's board type. It's like, I guess, a Boolean. You're saying, so that's likely a Boolean variable set in one of the headers in one of these libraries.
Well, it's a define set in one of the libraries, yes. Somewhere that they're going to say define that name, and it's going to, then that will just simply exist. So somewhere when you loaded up the libraries for your board is where it will do that. So then if you load up an Adafruit board that's called something else, they will put a define for their board type in there. And I know I went through that, and it didn't seem to match anything that I had. So then down at the bottom, I just put my own code and overwrote those.
You overwrote these.
Yeah, so I just put another block below all that stuff. I just put a block that just said define RFM 95 reset as whatever number I wanted. So I just basically copied that and just overwrote. So no matter what it wrote above, I could just, if you just copy those lines, duplicate those lines right there, they just had, and get rid of the if else and all that stuff, and just take those three lines, the three defines there, and as long as those are right in your code, you can just, the last thing that it executes, it should put that's the ones that it will use.
So, yeah, I'll go back to using their variable names then. Let's see if I can get this code to work. Now, this is concerning because this is using that instead of that. That comes from this. Because it's not, and it's not using that, it's using that to use that init.
You make your text a little bit bigger there. Okay, that's big enough.
So in this, what I'm drawing attention to is in the Adafruit example, it's checking to see if LoRa is initialized, and it's using an init under that. What's the right language? Instantiation. But I couldn't get, that variable to work there. It wanted the name of this function there. So that might be another change to the code. But I think this function will be available for that class. Anyway, that's where I'm at, is trying to get the LoRa to work so I can rejigger my e-stop and have the, what, it's okay to proceed signal back to the, no, at the lawnmower to say it's okay to proceed because it can still see and talk to the radio frequency controller. So progress, slow as always, but progress nonetheless. Yay. The other thing I'd spent some time on is looking at powering the LoRa board via solar power. This is a link from Random Nerd Tutorials again, like, you know, really good guys. And so I got my hands on one of these boards. I got my hands on this, I guess that's that technically a transistor, to wire up, we're up powering the lower board off of a solar cell to recharge a battery to output to powering the lower board. That's where I'm at. All good fun.
My video is really getting bad now.
Your redness. Looks like you're gonna burn.
If I block the light, it gets better, but yeah, it's just got problems.
So that's the sun coming in?
No, I don't know what it is. I got a direct light on me from the ceiling, and there's some light coming in from the outside. So I don't know what's causing it. So I'll try this again. Go back to this. Let's say blur my background. Okay, well, I'll run like that and see what it does. And it's my face isn't as red anymore, so we'll see what it does. So a long time ago, we were talking about possibly you'd want to measure the engine RPM on your lawn tractor, and people came up with lots of ideas, and they say, well, I'll measure it off the spark plug wire, or measure it somewhere else. And I kept saying, well, you know, it seems like it's got two perfectly good magnets that are spinning around on there. You can measure that with some kind of Hall effect device. And then I also noticed that mine has an alternator on it. And mine actually has an alternator with two different windings. It's got one winding that goes through a diode and goes back to your electrical system to charge your battery. And it's got a separate set of wires coming off to go directly to the headlights. So there's a separate winding on my alternator that drives the headlights with an AC signal. So I was given thought to which one of those. I think either one of those should work. And basically, no matter what your lawn tractor is, you should have magnets on the flywheel, and you should have some kind of alternator on the thing. You know, as long as it's a big lawn tractor, it's going to have an alternator. So let me pull up my videos here. How do I do this? Do this, do this, and then say share this. And then I never remember if these are blocked, so I'll move them out of the way. So this is a picture of an alternator. It's the stator coil that goes under your flywheel. Can you see that on your screen right now?
Roger that.
Okay, so this is not the one that I have, because this only has one set of windings. So coming off here, there's a black wire and a red wire. And then right here next to the connector, there's a diode stuck in there. So this is the one that goes back to your charging circuit. And I got another picture, just the bottom view of that. And this is just somebody's thing they're trying to sell me on Amazon or eBay or something. So mine probably looks like that, but it's got two extra wires coming out. And then it has, this is the two wires coming out to this plug for the headlights. And there's no diode in series with this. And so it's actually putting out an AC waveform. And here's the connector coming out. Here's the red wire and the black wire. And here's the diode in the connector. This is the one that goes back and charges my battery. So then if you look a little farther, the headlight is just simply a socket with something that looks like a turn signal light bulb in it. And then there's two of these in the front to light up in front of you driving around. So I think anytime the engine's running, these are on. I don't think they're switched or anything. And then so one day, I think sometime last summer, I put hooked my oscilloscope up to that socket. So it's got the yellow wire and the black wire and just connected them right to the headlight. And then if I look on the scope, this is hard to see because I was out in the sun. The sun's reflecting off the screen. But this is an AC waveform that's coming off those two wires right there. And this is running probably at idle speed. And if you go count these out, see down here at the bottom it says 2 milliseconds per division. And you count here from this zero crossing here, you got 1, 2, about 2.8 milliseconds is the frequency of that AC waveform coming off there. So if you run a few calculations, so you take 2.8 milliseconds, take the reciprocal of that, and they'll give you a frequency. And since the frequency, well, that'll give you frequency in hertz, or it'll give you revolutions per second. And if you want revolutions per minute, then you have to multiply that by 60. And then since my alternator has, as I said, I think there's a pair of coils here, and a pair here, and a pair here, and a pair here. So it's actually putting out 4 times the frequency of what it's actually turning. So you go back through, go back here, I said, 2.8 milliseconds, and take the reciprocal of that times 60, that gives you cycles per, let's see, but that would give you RPM times 4 because it's got the 4 poles. So divide that number by 4, and that should give you a number. So if I calculate this out, I think it comes out to like 2,400 RPM at this point, just by taking those numbers there. And then I did another one, and this is running probably the fastest speed. And I see I've got like 30 volts peak to peak coming off that. What the other one have? This one I think was 5, 10. This is about 20 volts peak to peak. Wait a minute, I don't know. No. Actually, I don't know what the voltage is. I got some others that have the voltages on. So anyway, this is a smaller voltage, and it's slower frequency, so the pulses are further apart like that. And then you go to the next one, it's running faster. They're closer together like this, and then it's a higher voltage. It's 30 volts peak to peak on that. And then here's another one that was, here I got some actual numbers here. So these say 5 volts vertical. So each division is 5 volts. So there's 5 volts. That's about 8 or 9 volts. And times 2 would be, about 18 volts peak to peak coming off that. And again, you can count the divisions here. And it turns out this over here is on the left. This is the cursors on the screen, and that's these purple lines. So there's a purple line right on this one right here. There's a purple line right there. So I'm actually measuring half of one full AC cycle. So technically, you'd still have to go from, say, this point. We can go back. We can go 1, 2. Let's see, back all the way back to this one here. So that's 2, 4, 6. That's 6 milliseconds right there. And again, if you run through the same calculation, I think it comes out to like about 3,900 or 4,000 RPM at that point. So it looks like I could measure RPM by reading the alternator that's on there. And I'm reading those off the winding that does not have the diode in it. So it's an actual nice AC waveform like this, just to run the headlights. And so on mine that worked. I think if you have the other one that just has the single winding coming off, you could just tap into in front of that diode, and I think you'll still get an AC waveform that you could convert. So it's just a matter of putting on something to convert this so your computer can read it, and then just doing those calculations on it. And this is a circuit that I found a website where somebody's talking about how do I measure the RPM by reading the spark plug wire, and they had all kinds of suspect circuits they were trying to do that with. And then somewhere down in there, somebody said, oh, well, eventually they said, take a ferrite core out of an old AM radio. So you got these loop stick antennas. So it's just like a piece of the the magnetic material they make antennas out of in those radios. They just wrap about 10 turns of wire around it. So when they say pickup coil, they're just putting this next to their spark plug wire. And they got this circuit to, it takes the AC and the diode cuts off the negative part and the transistor turns on the positive part and pulled up to 3.3. So out here, you're going to get a square wave of 0 to 3.3 volts as the thing's running. And that was, so they get these spikes every time the spark plug fires, they get a spike coming out of this thing. But I think the same circuit, this is basically the circuit I would make, except if we consider this as the coil on my alternator, the existing coil, I don't know if I need this load resistor. I don't know if I need this resistor between here and frame ground. It could be one side that's already tied to frame ground, like, you know, lots of people do that other stuff. And I don't know if I need these capacitors in here, but that's just this is the circuit I was thinking of. And I was able to copy this right off somebody's website and paste it up here. So that's basically what I'd have. So essentially this is the two wires coming in from the alternator, and then coming out here, I could connect that to like an Arduino Nano or whatever I want, just to measure the pulses coming out. And then you can either say, so once a second, you say count up the number of transitions, and then after 1 second, then that is revolutions per second, and then you multiply it by 60 to get RPM. Was it or because that's only going to update once a second. It's like the problem with GPS, where they come out of the box and it only gives you a reading once a second, so you don't know where you are in between there. Well, the other thing you can do is you go back to a waveform here. So I could count for 1 second and say how many of these I counted up, or you can just go from say this rising edge right here to this rising edge, and take the amount of time. What was I saying? This was like 6 milliseconds or whatever coming out to be. So you do the same thing there. You take the number of milliseconds, take the reciprocal, it gives you frequency. So just like I was doing manually, and that way, like 100 times a second, you're getting an update on that. So you're getting the speed very quickly, and then you could average that if you wanted to if it's too noisy. So anyway, that seems like a fairly easy way to, just connect two wires to it, and you can measure the RPM from your engine. So then the other thing is, since your flywheel has magnets on it, they're swinging around. And here's a sacrificial example here. Let me see, how do I do this? So here's a sacrificial example that this is just a little string trimmer engine that was laying around. That's going to screw up my video. So anyway, here's the flywheel here, and right here's the two magnets on the flywheel. So as it turns, these things just go around. Here's the magneto up here on the thing. So this is just like a miniature version of what is on a normal lawn tractor. Now this is on your electronic fuel injection one. You don't have this. You've got just a magnetic sensor here that picks it up. So but the thing is, the thing I'm talking about now would bypass your magneto or electronic fuel injection completely. Right. It's simply it's going to watch these magnets. Watch as these magnets go swinging by. It's gonna trigger the sensor. You get pulses directly off that. So I was thinking, well, that would work. So I foolishly went on Amazon and found, share screen, this one. So you can buy the sensors individually. They just look like little TO92 transistors, except they're flat. They're not like half moon shaped like a regular transistor. They're actually flat. You can solder 3 wires on it, and you can just glue it inside of take one of these and glue it to anything next to your flywheel, so I can see the magnets going by, and those should switch. Or you can buy those on boards like this. So I bought 5 of these. So it's just a little printed circuit board. Here's one of the sensors soldered onto it. When I got them, they were standing up on the board, and I bent mine over like they have here. And then it's got an LED on the board, so you can see when it's turned on. And then it's got little jumper, pins you can plug jumper wires onto if you want. And it's got a couple of mounting holes. So you can either screw it down to something, or just put some hot glue down on the top of your engine and just glue it right down to the engine, so the sensor can see the magnets going by. Or if you want a more industrial version, I found these. It's basically that type of chip packaged inside of a fancy little well, it looks like this. So this is just and here as an example, there's get too much stuff in the way here.
And that's going to fire on something magnetic passing by.
Yeah, so those two magnets on the flywheel that go around, as they go past it, that just triggers. So here's one of the turn off that blurring thing. So this is one of the proximity sensors that's similar to the one that Juan and Al, or Juan and Matt have on their back wheels, reading that sprocket as the thing goes around. And this thing's sensitive. You put up to some kind of ferrous metal, it turns on. But then you've got this one, which is the other one here. Here's the size comparison between the two. And this one has the Hall effect sensor in. So you have to actually put a magnet up to this one. You can't just put it up next to metal. And I'll demonstrate this in a second here. But anyway, it's got the the whole thing is threaded, so you just drill a hole, and it's got the nuts, so you just put it through the hole, and then of course it doesn't want it. There we go. Just drill a hole through a piece of metal or a piece of plastic or whatever, and then you stick it through, and then you can tighten the nuts down to hold it. So it's a much more industrial mounting than what the other ones are. Because other ones, I'd probably just glue them in place because I might be too lazy to do anything else. So, and then here's what the other ones I was saying I have is they just simply look like this once you get them. I just plugged a couple jumpers on to give me power and ground, and then I'm letting the LED. I'm just watching the LED on the board right now to see what it's doing. So that's several options to get your to detect the magnetic field. Let me go back.
I love the notion of, I'm reading the RPM off the headlight.
Yeah. So anyway, these were like two for $9, and this one back here was 5 of these for $6. So they're fairly cheap. And if you buy just the chip, these are 20 for $6.50. So they're even cheaper. But then you have to solder wires on them and put heat shrink over each wire. And then when you're all done, you can just glue it down to anything you want, just so it's close enough to the flywheel to see the magnets going by. So then here's that other one I was just holding up. This is the one. This is an actual proximity sensor, and it's got like a built-in oscillator or something. So it's generating its own magnetic field. When you get it close to something, then it activates and turns on, which is not what I want for the flywheel. So I wanted one that actually looks for magnets. I think I just got a couple more examples. Here's the data sheet on that. And they say here the detected material is iron and steel alloys, which means as you get it close to something, it turns on, whether it's magnetic or not. And then here's just a zoomed in version of the, so here again, they're saying detected materials, iron and steel alloys. Detection range 4 millimeters. I'm getting more like 10 millimeters. Well, no, this one I think is pretty close. It's about 4 millimeters on the detection range. But as I said, I don't want to use this on my flywheel anyway. It could be the flywheel in the lawn tractor is going to be a cast iron flywheel, whereas the one on this little engine I got laying here, I think is aluminum. So on the one with the aluminum flywheel, you got aluminum all the way around except for 2 magnets. But on a engine with a cast iron flywheel, the whole thing's going to be a big chunk of steel. So it could be that that would also cause problems. But since the Hall effect is only looking for a magnet, I guess that's into my photos there. Since it's only looking for, stop that, put these back over here. So I still think the Hall effect is probably what you want. So now let's do some demos here. So first of all, here's the which works. Yeah. So here I've got the one that's the proximity sensor that's simply supposed to respond to any kind of metal. And here's some pliers. So I just put it up close to the pliers. Let me get so you can see the light. Yeah. So as you get close to this, it does turn on. And basically I have to get really close to it before, so you can see the LED on the back of the thing coming on. So it does.
You're feeding at 12 volts?
Right now, this one I'm feeding 12 volts because it said, this one I think says 6 to 30 volts input, and the Hall effect one says 5 to 30 volts input. And so I'm just feeding it 6, and that I think it internally regulates it and controls everything. So anyway, that's just to show that it responds to whatever. Now,
before you put that down, can you grab the 2-cycle motor that you had?
Yeah.
I'm wondering if that LED goes off on, the alloy part of the flywheel. Well, it's on that's the housing, right?
Oh, on the flywheel itself?
Yeah.
Well, on this one, actually, the way it's built, see the magnets are down quite low. And most of the thing is that's just fins out there. So you don't have, I guess right there there's a counterbalance. So I don't know if it's what it's gonna do on that. Let me get it so I can get to it.
Hold it up next to the magnet and see if the LED illuminates.
Well, the thing is, when you get it close, this one that works like this, when you get it close to the magnets, let me do it here ahead of time. It looks like it's coming on. No matter where I get it close to the magnets, it looks like it's turning on because the magnets are a big chunk of stuff. So
I was wondering if if you could literally use those and it would be on constantly except when the magnet goes around. Sort of a negative.
What I thought I noticed was, and it might be on the other engine that I had. Oh, here's the other engine laying right here. This one's easier to see. So on this engine, so right there, there's the counterbalance part, and there's the magnets right there. And I was thinking on this one, it would come on.
Yeah, it's coming on with the magnet.
It seemed like it would in between it would go off or something. This turns on anytime it sees the magnet. Now it depends how close it is, but rather than worrying about all that, just avoid this kind completely because that's not what we're looking for. What we're looking for is something that turns on when it sees the actual magnet. So on one magnet it turns on, the other one it doesn't because it's should I say polarity sensitive. So on this magnet it turns on, and this one it does not turn on. So we can see that closer if we look at a.
I'll be darned.
They actually gave me a magnet with it. I didn't realize they're going to do that. They don't say anywhere, but they give me a magnet. It's just a little tiny flat thing, and it's probably like a neodymium, so it's a really strong magnet. And let's see, you get up to one side of it. So this way it turns on. If you flip the magnet over, it doesn't come on.
Huh.
And that's just some magic about it. But anyway, that's exactly what we want for something like this because we want it to just see the one magnet. And if I put it up to, so I'll just stick it in a spot here where this is normally where the air comes out of the thing. Let's see if we get this so you can see that. So I turn this around here. Oh, so that's not going to come on. That's not coming at all. Maybe I made my wiring fall apart.
Like your supplied magnet.
It's still working, so. But anyway, it does just respond to one of the two magnets as it goes around, and it doesn't seem to respond to anything else while it's turning. So I think these would work. Or then I've got the other one, which is the. What I did, I just took the sensor, and I've got to cut off USB cable just to get +5 and ground. So I just plugged that in the computer to power it. Plug that in there. And this one should work the same way where. Let's see.
It came on.
Yeah, it did, but that was backwards. As you move off center, then it comes on even though it's backwards. So here, as I get close to it here, that it does come on. So I move back and forth this way. It should. See, that works also. So basically, this works the same way as that. The more industrial one is just simply that these are cheaper and might be easier to mount because you can put it just about anywhere. If you're just going to glue it down, say you could hot glue it down, or maybe hot glue is not good because your engine warms up, the glue might get runny. So you can epoxy it down or something. But so anyway, that's another option. So basically, you just put this somewhere next to the flywheel as it's spinning. And I was noticing this one, I could get like a 1/4 inch away from the, at least this magnet that I've got. And it's gonna be hard to see, but it's about a 1/4 inch away and it turns on. So that means you don't have to get real close to the flywheel, so you don't have to worry about hitting the flywheel while it's turning. So I think that would work out fairly well.
And where did you get, where did you source the more industrial magnetic sensor?
That stuff is all on Amazon. That's where I got everything. Let me see, how do I go back to where I was? Share screen. Back here. And so it's just out on Amazon. It's the NJK-5002C. You got, I always want to remind people of this because people sell the stuff on Amazon and eBay, have no idea what they're selling, and they'll cram as much stuff into the title as they can. So it's left up to you to figure out if it's what you want or not. So that the other one that's the proximity, the one that really is the proximity sensor, this one here, the one with the blue tip on it, that one, they just call it a proximity sensor. Here they call it Hall effect sensor proximity switch. So you don't know if it's a Hall effect switch or a proximity switch. So what you have to do, and then down in the comments, people are saying, well, it doesn't do what they claim. It's really a reed switch because you have to supply a magnet. Well, oh no, it's really a Hall effect sensor. And what you have to do is you have to pull up this the data sheet. So it's NJK-5002C Hall effect. And you go search for that on Google, you can find an actual data sheet for it. And they say right there, yes, you need to have a magnet to make it work, which is what I wanted. I wanted that for, since I'm trying to look at the magnets on the flywheel, that's exactly what I wanted. And depending where you buy these, somewhere on eBay, they wanted one for $12. And somewhere else on Amazon, they wanted two for like $20. And this is the cheapest one I found. I could get two of them for about $9. So I got two of them that I can play with. And so if I blow one up, I got two shots at it. So I think either one of these methods should work to measure RPM. So if I get around to it, I need to go unbury my lawn tractor and see if it'll start. If it will, then I can pull the flywheel cover off and mount these on somehow and run the wires out, and then I got something I can play with. So I guess that's really all I had to say on that stuff. So that's something else that I may or may not play with if I get a chance. And even on yours that has electronic fuel injection, you don't care because if you got that flywheel that's spinning, and it's got at least one magnet. I don't know if yours has one magnet or two magnets on your flywheel, but as long as you got one magnet there, it's got to be the correct polarity for the Hall effect, which I guess the little one that's on the board. Let's see, what am I doing here? Stop sharing. So on the little one here that's got just the little flat sensor, you mount it this way, or you can turn around this way and mount it. So that way you can change the polarity to the magnet if it's one way or the other. So that'd be a way around that. Whereas if you got this one, where is it? You got this one and the magnets are going by. Well, if your just has one magnet on the flywheel, it may or may not be the correct polarity to sense on this. So that'd be something else to consider. And I'm sure yours has an alternator built into it. I'm sure any of the bigger engines have an alternator. And theoretically, you could tap into the wires on that and do it this other method that I have, which I haven't actually proven that'll work, but I can see it on the scope and it looks like, all reasonable stuff. So I think that will actually work.
Yeah, probably have to, on the fuel injection model of the Cub Cadet, probably have to tap in the alternator as opposed to the headlights. I think the headlights were LED, which means
I think mine's probably unique, and it's a cheap piece of crap, and that's why they wired that extra winding into the headlights. But I don't know. I don't know if that's true or not. And it might even be putting out a higher voltage on that. I'm guessing most of them are like that first thing I showed, where they're just the two wires coming off the alternator, and then they do whatever they want with that. So you on yours, you may not have that option. Mine, I have that option. Or as I say, I could back up and tap it in front of that diode and get an AC waveform coming off that, so that if I had to, I could do that. And probably anybody, could do that if that's what you have on your alternator.
It just sounds so much fun, more fun though, to say, yeah, I'm monitoring my RPM through my headlights.
Yeah. I'm not sure my headlight. I think one of my headlights worked, that one was burnt out, but it's just, so it could be if there's no headlight load on it, I get a higher voltage, but I only need like 0.7 volts to trigger my transistors. So it doesn't really matter what it's putting out, as long as I don't have a high enough voltage that's going to blow everything out, then it should work no matter what. I'm also
happy to know. Go ahead.
I was also going to say that that one circuit that I showed, that I said I could probably hook up to my headlight circuit, I could probably put that on my primary side of my magneto and read the high voltage pulses there. Those are like 200 volt pulses that I think will be there. I've never put a scope on and checked it, but I might have to modify it slightly, put in higher value resistors so it doesn't blow anything out and doesn't. The other problem is you start connecting into that. If you load it down too much, your engine's not going to run. That's another issue. And you hook anything up to it, maybe your spark's going to be temperamental. So I'd rather not do that at all. And like on your fuel injected model, you don't have that option because that's not the way it works. So that's why I was thinking either just watching the magnets go by or taking off the alternator might be a good way to do that.
Yeah, I'm just, it's been a while since I had the housing off. I'm wondering where to connect that Hall effect sensor. By the way, Google responded to me typing in Hall effect proximity sensor. And it came right up.
Yep. So remember, it's up to you to figure out what the difference is between those.
Yeah, so when you want a Hall effect proximity sensor, and, that's cute.
And the one that's a proximity sensor might have a more elaborate name. They might call it an inductive proximity sensor or self-excited proximity sensor or something. I don't know what they actually call that. So other things you could do is you could put put a reflective strip on your flywheel and get one of those little optical devices that's like a reflective optical device. So every time it comes around, it gives you a pulse where it sees it. But again, I worry about that being temperamental, and if you get any extra light under your engine, under the flywheel cover, it might have problems with it. So I'm just thinking those magnets are there. They're nice and strong. As long as you just get something close to it and they come on, I think that will work. That should work on just about any engine that has, unless it's an engine that doesn't have any magnets on the flywheel, that it's not going to work. But I think everything I've seen so far does have those.
Cool.
So that's what I've been thinking about, and I just got those parts a couple days ago in the mail, so I tried them out just to verify. Yes, they do work, and I'm thinking that this would actually work.
And what are you doing with the extra flywheels lying around?
Doing what? These engines laying here?
Yeah, how did you end up with extra flywheels lying around?
Well, it's not an extra flywheel. It's an extra engine. It's a full engine here. This is a string trimmer. I collect these because I figured people are going to throw them away. I'll take them and maybe do something good with them. And this is one of the few that I found, this brand. It's got a long enough shaft on the front. You can put something onto it. Most of them just have this. Most of them will have a centrifugal clutch, and it's got this little hole, like a square hole or a funny little hole that drives the cable that goes down. But this particular brand has the long shaft on the front, and I've got a pulley here that's bored out to fit right on there. So technically I can actually use this for something useful by doing that.
And what sort of RPM do you think that thing hits?
This little one, I don't know. They really scream. These are like 7,000 RPM or something. These run at. And your lawn tractor probably, typically on an engine like that, they'll say 3,600 RPM is the normal running speed. And what I saw on my AC waveform tells me it's turning like like 4,000 RPM, so it's actually turning faster than what I expected it to. But it's just up to you what speed you run it at, I guess. So the whole point is I just want to be able to monitor that and know how fast it's turning.
Interesting. Yeah, you see a number of those 2-cycle engines. That's a 2-cycle one, right?
Yeah, most of them I have are 2-cycle. I've got 1 or 2 that are a 4-cycle. I got one string turn that's a 4-cycle, which is a newer. I bought that one for $5 at a hardware store. They say, oh, this stuff's on closeout, because apparently somebody kept returning it, or they returned it once. They couldn't keep it running. And I bought it for $5 and brought it home and played with it, and it got it to run. And so, but again, it's one of those that's gonna be real hard to hook up to anything because it's got the stupid little clutch, and it'd be hard to adapt it to anything. But it's just more junk laying around.
You need a big barn.
Yeah.
Okay, well, I got a note from Bob. Bob was asking me about cows. I don't know. His question was unclear. No, he didn't reply to my response. Anyway. Bob, if you're out there, I sent you a reply to your note. I was wondering what questions you had about cows, managing cows.
Was it on Slack channel, or was that a private one, or is that something? I didn't see anything like that go by, so I don't know.
Yeah, it was a private one. He said, we don't have livestock anymore, but I'd be interested in hearing about managing your cows. And I just told him I had this small herd. I think we've got 17 at the moment, and they're all grass fed. Anyway, yeah, I'm not big like Juan. I think they have 10,000 or something crazy.
Huh, that's a lot.
Okay, we can turn recording off.